Hi, thanks for joining me in this video. We're discussing temperature sensors, and specifically we're looking at thermal expansion types temperature sensors. And in this discussion we're going to talk about bimetal strips and also Birdon tubes. The bimetal strip thermometer is one where you have two metals that are bonded together, and the metals are different. They have different thermal expansion coefficients. So in other words, one of the metals will expand more than the other as temperature changes, or conversely contract more than the other as temperature changes. The two metals are mounted so that the center of the curved bimetal will result in a curling or uncurling of the sensor. The end of the sensor is attached to an indicator, and the indicator has a display which indicates, of course, the temperature. So as it heats up, it'll kind of curl out. As it cools down, it'll curl in, it'll get smaller, and you get indications of temperature on the display after it's been calibrated. There's an example of a bimetal thermometer. You've probably seen one of these before. They're typically used for outdoor thermometers, and the reason is because they're very rugged, but they do have some limitations. We're going to talk about their limitations here shortly. Here's a little bit of the theory behind a bimetal strip. As we see here, one end is anchored, the other end is allowed to freely deflect, and we measure that deflection from one point to another as temperature changes. We're going to call that Y, the measure or the distance that it bends. Here's the equation for the bimetal thermometer. It shows the deflection is dependent upon, of course, the constant of the two metals, also the temperature difference between the ambient and reference temperature, the length of the strip, and then also the thickness of the strip. If we want to find out the sensitivity of a bimetal thermometer, we need to take the equation that we have at the top and take the derivative with respect to time. So how does the bimetal deflect with temperature? In other words, the change in deflection with the change in temperature. And that's what you see in the bottom. That equation says the sensitivity is of course, change in the deflection with temperature. If we take the derivative of the right-hand side, we end up with just K L squared and T in the bottom. K being the constant, L being the length, and T is the thickness of the metals. So the sensitivity of a bimetal thermometer depends upon the square of the length, and also it's inversely proportional to the thickness of the strip. If you want a very sensitive bimetal thermometer, you want to make sure that it has a very long strip of metal, and that's why they curl the bimetals. Typically, as you saw in the previous slides, they were curled. If you uncurl that, if you lay it flat, you'll notice that the length is significant. The other way to make a very sensitive bimetal thermometer is to make sure that the thickness of the strips is not very much. Make sure that it's rather thin, and that'll improve the sensitivity of your bimetal thermometer. Bimetal thermometers are found everywhere. They're used in buildings and houses, apartments. You probably have one as a meat thermometer. Use mine for the grill. I have it outside on the grill. And also I have one outside mounted to one of the windows so that I can see what the temperature is outside. Here's some of the metals that are used in bimetal strips. They use iron, Invar, steel, brass, but here's some coefficient of expansions for iron and brass, and you can see they're different. As a result, you're going to get a deflection in that metal strip. Some characteristics of bimetal thermometers: they're not very precise, and they have a very slow response time, on the order of 5 minutes or more. But it depends upon the size of the thermometer. Also, it's subject to corrosion. Remember, this is metal, so metal does oxidize. But however, it is pretty rugged. I mean, you can drop them and they don't really do much. They don't break or anything. The next type of thermal expansion thermometer we're going to talk about is the Birdon Tube. And the Birdon Tube is a curved metal tube that is elliptical in cross-section, and usually it's filled with some sort of fluid. And it's very similar to the bimetal in principle because you have thermal expansion coefficients of the metal and the fluid that are different from each other. So as the fluid expands, as the temperature increases, the fluid expands, so the volume increases, and the tube becomes more circular in cross-section. It kind of straightens out. If you fix one end, allow the other end to move freely and attach it to an indicator, which is indicating on the display, you've got yourself a thermometer. Here's the equation for a Birdon tube. It's rather complex, but it does depend upon the curvature, the length of the tube, the curvature of the tube, and also the coefficient of thermal expansion for both the fluid and the metal. Birdon tubes are used mostly for thermographs to record temperature over a period of time. They're more expensive than bimetals. Bimetals are pretty cheap, but Birdon tubes are more expensive. They're not as rugged as bimetals because they have a fluid inside that may leak if dropped. They have a very slow time response similar to bimetals, and they have a large hysteresis error. So that's a little bit about bimetal thermometers and also Birdon tubes.